Alright, people, we can do this. We'll get that. Okay. Wait, so like that, and then... No. Like this, and then that. Oh, it's gonna get toasty under here. Alright, let's do this. Welcome back. Day 5, Advent of Code 2023 enclosure. I'm already warm under the head, so we have to solve this fast. Day 5. If you give a seed a fertilizer. I think that's kind of like a joke on the whole. If you teach someone to fish, if you give someone a fish. I do want to read this. We will. You take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone has food that I completely forgot to check why we stopped getting more sand. There is a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to his request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived and we are having trouble making sense of it. Okay, it's just linking to what an almanac is. The almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category, so that is soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. Fair enough. For example, seeds 79, 14, 55, 13. Seeds to soil map 50. Does it go like this? 50 to 52? Kinda has to, right? Soil to fertilizer map, fertilizer to water map, water to light, light to temperature, temperature to humidity, humidity to location. Okay. The almanac starts by listing which seeds need to be planted. Seeds 79, 14, 55 and 13. Yep. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with which seed, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers. That can be converted. Each line within the map contains 3 numbers: the destination range start, the source range start, and the range length. So consider again the seed to soil. So the first line has a destination range start of 50, a source range start of 98, and a range length of 2. This line means that the source range starts at 98 and contains 2 values, 98 and 99. The destination range is the same length, but it starts as 50, so 50 and 51. Okay, that makes sense. With this information, you know that seed number 98 corresponds to soil number 50. And then seed number 99 corresponds to soil number 51. The second line means that the source range starts at 50 and contains 48 values. So it goes from 52 to 99, right? 52 to 99, so the seed number corresponds to certain, any source that aren't mapped corresponding to the same destination. Any source numbers that aren't mapped correspond to the same destination number. So Seed number 10 corresponds to soil number 10. So the entire list looks like... Okay. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you can find its corresponding location number. In this example, the corresponding location is like seed 79, soil 81, fertilizer 81, water 81, light 74, temperature 78, humidity 78, locations 82. Wait, to do this you need to correspond. Then seed 14 goes to 43. Seed 55. What is the lowest location number that corresponds to any of the initial seed numbers? So do I just need to like go through this list? Go through this list for all the seeds? And then I just end up with... Okay. Okay. I'm not quite sure I fully understand. But I think we just have to go through all of these and then just find the lowest location, and that's what we return. So what I'm thinking is I mean, it already says map, right? And all of these structures would be really fast as a map with the lookup. Okay, so let's take all of this. This is going to be a great input. I'm just quickly going to type this out. All right, we're back. Typed it all out. Well, not typed it all out, but whatever. This is failing now because we return nil. That makes sense. We have the almanac here. So, what I'm thinking is if we just hack straight at it, or write smaller tests. So what is a simpler test that we can think of? So single lines, right? And if we have a seed, it's just like 1. And then we say 1, 1, 0. Then this should return 1. So returns 1 for when all maps, or like when maps 1 all the way through. And that's not really useful yet, because if we just run this and we just return 1, then oh, sorry, I should actually like update this, right? And this passes. But if we returns to when maps all the way through except for location, and let me see again. The first bit was the the first bit was that is the destination and that is the source. The source range starts at 98. So if we say the source is at 98, but the destination starts at 2, then that should be 2. Right? And that fails now, because it's still returning 1. So we need to get into parsing this. Def n parse all. So if we split, is this effectively a double new line, right? So if we do a string split raw almanac, string split the raw almanac at \n. So seed to soil map. No, I don't quite understand. Hold on, let's look at the input, because otherwise, just to make sure. Okay, so forget about this. No, actually. No, it should be fine. No, it should totally be fine. So if we have seeds like this, and this is a I just don't. Is this just a problem of printing it? I'm gonna import pretty print. Always helps. Ah, yeah, no, lovely. Lovely, lovely. That's what we want. Okay. So and that is always the same. Seed to soil, soil to fertilizer, fertilizer to water, seed to soil, soil to fertilizer, fertilizer to water, water to light, light, temperature, temperature, humidity, and then humidity to location. Okay, so we always have let raw seeds, raw seed to soil. Oh no, we're gonna do this differently. So we're gonna do this, and then it's still like ampersand mappings of this. I think it's with ampersand. But yeah. And then what we're gonna do is seeds is relatively easy because seeds is just map. So the first is RE sequence over digits over raw seeds. So that just gives us one in that case, just to quickly try. Yep, okay. And then map parse long. So, got our seeds. That was easy. And now the mappings. Seed to soil. Soil to fertilizer. Fertilizer to water. Water to light. Light to temperature. Temperature to humidity. And humidity to location. Location, if we would actually spell it correctly. And that would be map, parse, mapping over raw mappings. And this is where the actual fun starts now. Parse, define. Parse mapping over a raw mapping. And what we want to split out is a map. That's what we want to do. We want to split out a map. Or immediately a function that we could call. We'll see. We'll see. Let's try dealing with the mapping first. So the first thing that we need to do is let map lines or mapping lines be string slash split lines over raw mapping, and we want to take the rest because the first line is going to be this, which we want to drop. So seed to soil, this is that parse mapping, this is going to return that seeds. So let's return first off just seed to soil here, and then return seed to mapping lines. So if we do this, we should, well, unexpected. A persistent vector chunked sequence cannot be, is not, oh, hold on, yeah, that's correct. I don't want to call this. So 110, that is this. And if we would have another line here, 2, 2, 2, then we should get both of them. Cool, so those are our lines, right? That makes sense, hopefully, so far. So now we need to convert those into mapped or like parsed lines. We're gonna map over binary sequence. We're gonna pull out the digits again. Percent over mapping lines. And then we return the parsed lines here. Amazing. And now we need to turn each line into a map. So mapping line to map. So that is destination. Oh, and should we do a map RC map parse long over this? Alright, numbers. There we go. Cool. So destination start source start length. And if I remember correctly, you can use vec and pass it two vectors, and it's gonna... No, what am I thinking of? Map vec. No. To like grab the first of this and grab the... I thought it was like map. One second, I'm gonna look this up. I've done this before. Vector is what I'm thinking of. So the difference is vector closure docs. Vec creates a new vector containing all the contents of collection, whereas vector creates a new vector with the individual items. Okay. So, and what I'm thinking is, if we do an into a map over map vector, and what we need is we need a range of source start length source start and length. I feel like I'm off by one, or I'm off here. Over destination start plus length. I just feel like this is gonna help us. Like, I feel like if we do mapping line to map over the first parsed line, then I feel like this should now be a map of like all sources to destinations. Or it's nothing. Because we always have to go +1 because it's exclusive. So this is now a map from 1 to 1, and if we say 2, then it should be 2 to 1. Yeah. And if we say 1 to 1, then I would expect it to be a vector of 2 to 1 and 3 to 2. Yes. Yes, 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 yes. I think this is gonna be very successful. Okay. But we want to do that for all of them, and then we want to merge them. So we want to merge map, mapping line to map, parsed lines. So this means if we have like multiple lines here, like 2 to 2, then apply merge. Then we want to end up with one big map at the end for all of the mappings. Lovely. Lovely, lovely, lovely. Okay. Oh, I'm feeling good about this. I'm feeling good about this. This is, I hope this is not gonna break me later. Okay. Now the question, if these are in order and those are lists already, then we just have to like thinking of like breaking these out. Sure, fine. But actually, if we just keep them in order, we're just gonna go through the first one to that and then put it in here anyway, and then that to here and that to here and that to here. So I feel like we can just keep them in like all of the mappings. And then what we return here, the almanac is seeds, and mappings. And then we have this great almanac here. Everything's nice and lovely. And then what we need to do is we need to find location for seed. And what we're gonna do here is we're gonna go over, is it a reduce? I feel like it's a reduce. Get mapping current. That's gonna be our new one. We start with the seed over all of the mappings. And if we spell this correctly, then that might be useful. And what we return now is we're going to do this for the first one. So we're going to do location for seed over first seeds almanac. Well, actually it needs to go in a let. Let almanac. And the location for seed is also going to need the mappings of almanac. And that passes. That actually passes. So one thing I want to capture explicitly first is when we don't have a location. So it returns 1 when maps all the way through. And humidity to location not mapped. So what I mean by this is where we said like there might be no source mapping, right? So we could say this maps all the way through as a 1, but then actually the location map only has something for like the 2, and the instruction set then it should just return Did it say the seed itself? I hope it didn't say the seed itself. I think it just meant whichever number we're at. That aren't map corresponds to the same destination number. So, yeah. Okay, so I think basically if we run this now, it would return nil. Yeah, because it gets all the way to the end here, but then it's like, I can't find this. So actually what we're going to do is get supports the default return value. So we're just going to say current. So if we can't find it, just return the current value of 1, not 2. There we go, that works as well. So that means if we now map all locations and then get the lowest. So first sort map partial location for seed mappings almanac over seeds almanac. No failures. Okay, let's quickly rewrite this. So we raw almanac, we do seeds almanac over map partial location for seed mappings almanac sort first. Puzzle input. Puzzle input. Please don't fail me. I think it's slow. I think this is very slow. But how slow? Something we should wait for or something we need to analyze? Okay, let's quickly terminate this. Mapping line to map. Okay. Yeah, let's see. Oh wait, is this still? Let's kill the whole thing. Mapping line to map. Okay. This takes very long. Very, very long. Okay. What does take so long? I hope not the... Okay, let's... mapping is string re find C2 are second, so mapping is second of this. I refined that's print line parse mapping for mapping, and then we passed it in. That's the bit, so partial mapping. Well, I guess we know actually. Why did I do that? We know where we are. Whatever. Let source range destination range vectors map vector source range destination range and then into vectors print line source range building source range building destination combine into vectors and then into map. So where are we slow? into map. The into map is really slow. How slow? Parse mapping for mapping. What was it again? Alright, just gonna let this run and see how long it takes. So we have 1, 2, 3, 4, 5, 6, 7 of these. Did it just... Oh. Oh no. That's for each individual line. That was just for a single line. Where's my input? That was just for this. And that took like a minute. Okay, no, that's not gonna work. That's gonna take way too long. Like, that's 20 minutes for a block. I'm not gonna sit here waiting an hour. We need to think of something else. Oh. Okay. Okay. So that's not gonna work. So if we... Let's kill this. A different option is we have like a number we're looking for, like 4. And we have a source, start, and a range, right? So it is within a range if uh, 4 is larger equal to source start, and 4 is smaller equal to source end. And then the offset would be source start minus, no, number minus source start. And that would be like an offset. And what we can do is we can use the offset on the destination start plus offset gives us where we land. I think that's what we're gonna do. And if we can't, and if it's not in any, and yeah, okay, so mapping line to map, we can, so sad. Would have liked this to work, but okay. Def and mapping line to mapping. So destination start source start length. So actually all we care about then is destination start, destination end is destination start plus length. Oh no, source is what we care about. And then destination start. So so okay. And we do this for, so this goes, this doesn't work. We do this for all of them, and we don't merge them. We don't merge them anymore. We just keep them as a list. So that's a list of mappings. Right? That's not gonna work, so we just quickly comment this out. So start the REPL. Let's give this a go. Okay. Plus canopy caster. Oh, what am I doing? So source start, source end, destination start, source end, destination start. So it's a list of lists. That is a list for the first one, that is a list for the second one. Okay, so if we add a second one here, 2 to 2, then we should end up with source start, source end, source start, source end. Yes, okay, perfect. So, and then let's quickly try to see if we can parse that almanac rel. Yeah. Okay, way faster. Good. So now we need to find the location in the seed. So this is going to be a little bit different now. So def in source in destination, source in mapping. So that takes a source and then a mapping. And what did we say up here? We say like basically this bit. um, if and bigger equals source, then source start of mapping, and smaller equals source end, then mapping. I guess not if, but like a when. Then what we return is plus destination start of minus source. Should I just break these out? Keys, source start, source end, destination start. Minus source start. So reduce if source in, or if let found destination is this is hurting my brain now. So we have this is all mappings. So this is all mappings. So reduce seed over the mappings and then source in mapping. And then this is basically like source in range. Def and source in mapping takes a source and a mapping. And a mapping is a list of things. So reduce fn. Oh, no, reduce here, right? So like first, any partial source in source over mapping. Not any filter, right? No. Sum. The first. And found like destination is this. And if we have it, and otherwise we return the source. I think. Oh. that currently doesn't work, right? So no. Okay. Don't know how to create iSequence from Java long. That passed. All of these pass. All of these pass. This gives me a number, but is it the right number? It is the right number. Yes. Ooh, okay. Part 2. Everyone will starve if you only plant such small number of seeds, of course. Reading down one, it looks like the seeds line actually describe ranges of seeds. Of course it does. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range and the second value is the length of the range. So in the first line, it's 79 plus blah. Now rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers in the above. The lowest location number can be obtained from seed number 82, which corresponds to soil, blah, 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 blah. What is the lowest location number that corresponds to any of the initial seed numbers? Okay, so that seems fine, right? "27 seed numbers because 14 and okay. I mean that should be that should really be simple, right? Or am I? Part 2. All right, I let my solution run overnight just to see if it even comes up with the right one, with the right answer, and it didn't. I don't know how long it took to run. I didn't time it. It is wrong. So I'm gonna call quits on part 2 of day 5, which is very, very disappointing. But yeah, I think what I might do is I might ask someone from the Clojure community if they're interested in hopping on a call with me. But yeah, we'll see. It's gonna be a second video. So sorry about that, but that's what it is. I hopefully see you in day 6.